Hi, my name is Caroline Akerley, and today I'll be talking about Lab 1 charge tapes. Materials can have either an excess or a deficiency of negative charge if they undergo processes such as rubbing, pulling apart, or touching other objects. This excess or deficiency of negative charge can be in the range of 1.6 times 10 to the negative 19 coulombs and 1 times 10 to the 5 coulombs. This still leaves a large range of possible charges. The purpose of this experiment is to create charged pieces of clear tape, observe the interactions with objects of different charges, and determine the amount of excess or deficient electrons that have been transferred to the tape through contact. The fundamental physical principles used in this lab are as follows. Similar charges repel while opposite charges attract. When a charged object and a neutral object interact, the neutral object is polarized, meaning that a temporary dipole is created and it becomes attracted to the charged object. The definition of the electric field is E equals K times Q divided by R squared. The definition of force due to electric field is Fe equals E times Q. And the definition of force due to gravity is Fg equals M times G. In order to create a charged tape, place the base tape on a smooth surface. Measure the upper tape, or the U-tape, to be 20 centimeters long and create a handle on the end by folding it over. Stick the U-tape to the base tape and then quickly remove the U-tape. To check the charge of the U-tape, attach it to the side of a table and move your hand towards the tape. If it moves towards your hand, then it is charged. In order to test the interaction between two U-tapes, first make two U-tapes following the previous procedure. Set up two books and place one U-tape on them. This will be the top tape. Hold a second U-tape, the bottom tape, under the top tape and slowly move it up towards the top tape until it begins to float. Measure the distance between the two tapes when the top tape starts to float. Use the fundamental definitions of electric fields and forces to find the excess charge on the tape. My expectation for this experiment was that the two tapes will be repelled from each other because they are the same charge. My observation was that this was true. The tapes were repelled when the bottom tape was brought 0.011 meters from the top tape. On the top tape, there is a gravitational force pushing down and an equal but opposite electric force pushing up on it. Because of these forces, the net force in the y direction on the top tape is 0. On the bottom tape, the gravitational force and the electric force push downward, and the force from your hands pushes the tape upward and exerts a force equal to Fg plus Fe. Because of these three forces, the net force in the y direction on the bottom tape is 0. To find the excess charge on the tape, I first had to find the gravitational force by doing m times g. I found it to be negative 1.96 times 10 to the negative 3 newtons. I then used the formula Fe equals negative Fg, which is also equal to E times Q, and solve for Q. In order to find the number of deficient electrons, I divided Q by the charge on electrons. To find the number of atoms on the surface tape, I did the area of the tape divided by the area of the atom. To find the ratio of deficient electrons to total atoms, I divided the deficient electrons by the number of atoms on the surface. I found the excess charge on the tape to be 5.133 times 10 to the negative 9th coulombs. The number of deficient electrons was 3.20 times 10 to the 10th electrons, and the ratio of deficient electrons to total atoms was 3.208 times 10 to the negative 7th. I used GlowScript to model what was happening in the experiment. The green arrows show the electric field forces, the yellow arrows show the gravitational forces, and the orange arrow shows the applied force from my hand. A scale factor was used to show the forces and to make sure that they were easier to see in the actual diagram. The position of the gravitational force and the electric force were altered on the bottom tape so that they could be seen in the diagram rather than being on top of each other. We were asked two questions regarding charges. The first one was, what if electrons had a positive charge and protons had a negative charge? In this case, the U-tape would become negatively charged rather than positively charged. Because both U-tapes would be negatively charged, they would still interact in the same way with each other. They would be repelled. The U-tapes would still be attracted to neutral objects due to temporary dipoles, and the U-tapes would still be repelled from the negatively charged pen. The second question was, why is it important to handle the charged tapes as little as possible? When you handle the charged tapes, every interaction lowers the charge on the tape. When the tape comes into contact with other objects, electrons from the object will move to the tape in order to reach neutrality. In order to be accurate, the tapes should be handled as little as possible so that electrons are not removed.